Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic in which we are going to study inverse Z transform of signals with complex conjugate poles and when numerator degree is greater than denominator. Here we are going to study two different topics. First one is signals with complex conjugate poles and another one is signals with numerator degree is greater than denominator. So first three numericals are based on complex conjugate poles and next three are based on when numerator degree is greater than denominator. Now we will start the first one in which we are going to study when a signal or a signal with a complex conjugate poles. Problem number 1. Problem number 1. Find inverse Z transform of x of z and the function is 1 plus z inverse. In denominator we have 1 minus z inverse plus 0.5 z raised to minus 2. Now if you are going to factorize this denominator, then what are the different factors you will get? Well, basically the last term is always product of two digits. So let's say, suppose if I want to obtain 0.5, then I can say that 0.5 is a product of 0.5 and 1. But the midterm is always addition of two digits. That is, if we add 0.5 with 1, then maybe you will get answer 1.5 or minus 0.5. But here we have a value minus 1, which means we can say that here the factors are complex, or you can say the poles are complex conjugate poles. Now how to deal with this complex conjugate pole, I'll tell you. So first of all, our function is over here. Basically what we want, inverse Z transform, and we can obtain inverse Z transform using partial fraction method. But first of all, what we want, the factors or the poles of this function. So how to calculate the poles of function? We have studied one formula, minus b plus or minus square root of b square minus 4ac upon 2a. Using that formula we can obtain the factors or the poles. In denominator, the highest power of z, or you can say the coefficient of highest power of z, is nothing but a, or you can say the constant is a. Now next one, next to lowest value, that is z inverse, and the coefficient of that z inverse is b, and the last, that is z to the power minus 2, the coefficient is nothing but value of c. Now we will substitute all this value in our equation. Here my a value is 1, b value is minus 1, and c value is 0.5. So I'll substitute one by one all of this value. My b value is minus 1, so I can write minus 1. Now in square root, first one is b square, that is minus 1 square is 1 always. Now 4 into AC, here my A value is 1 and my C value is 0.5. And whole divided by, I'll multiply 2 with A and A value is 1. So that is 2 only. Now we will solve a numerator part. Minus into minus, answer is plus 1. Plus or minus, inside the square root what we have, 1 minus 4 into 0.5. 4 into 0.5 is always 2 and whole divided by 2. Now next one is, we know that 1 minus 2 is minus 1, and if we take the square root of minus 1, what we will get? Answer is j only. So the poles of this given function is, we can say, half plus j 1 by 2 and half minus j 1 by 2. Now look at here, here the real part is same as well as the complex term is also same, but sign is changed, which means this is a complex conjugate pole. Now I'll substitute this pole value in our function. Now I'm going to substitute all values of poles in my function x of z. But first of all, moving to poles, I'm going to convert all this z inverse into normal z. So what I'm going to do, first of all, I'll write whole equation or a whole question as it is, and then I'll substitute the z value, or I will multiply numerator and denominator by z square, and then I'm going to substitute the poles value in my function. Now, here I said I'm going to multiply numerator and denominator by z square because the lowest value of z is over here, the z to the power minus 2, or you can say the power, lowest power of z in denominator is z to the power minus 2. So to become or to write this equation in the positive order of z, we have to multiply whole numerator and denominator by z to the power 2. So first of all, I'm going to split z in two parts for numerator. First of all, first z I will keep outside the bracket, and second z I will multiply inside the bracket. So 1 into z is z, but z into z inverse, answer is 1. Now the reason is, if I multiply z with z to the power minus 1, what you will get? Here the bases are same, so powers always get added, and 1 minus 1, answer is 0, and z to the power 0 is always 1. That's why here I have written 1. Now if I multiply z square in the denominator, then what you will get? Z square minus z plus 0.5, because here also z to the power minus 2 and z to the power 2, the powers are gets added, and then you will get a 0 in the power, and z to the power 0 is always 1. So 1 into 0.5 is always 0.5, and this is my x of z. Now here I will keep one z on left hand side, as well as I'm going to substitute the values of poles in my function. Now if we have a two poles, then of course we will use a two constant, that is a and b, because we are going to solve the inverse z transform of this function using partial fraction method. So let's say my first constant is a, and denominator of b I'll write z minus half plus j by 2. Now just cross multiply this both this denominator, then what you can say, this z minus half plus j by 2 multiplied with a, similar this one is also multiplied with b, and the whole denominator, what you will get in the denominator, we will get the product of these two. And if I multiply this denominator on, or if I shift this left hand side denominator on this right hand side, then both the denominators will get cancelled. So what you will get, you will get z plus 1, and a will be multiplied with, as I said, so this will be my equation number 1, and the next one is my equation number 2. Now we'll substitute z value to get values of a and b one by one. Now I'm going to substitute z equals to, if I want to remove b, then I'll perfectly substitute the opposite value of this pole. Then if I substitute z equals to plus half plus j by 2, then these two terms will get cancelled, and automatically I'll get the answer of A. Now remember one thing, in complex conjugate poles, if you're going to solve a numerical which is a complex conjugate, or you can say which is having a complex conjugate poles, then you can solve this question in two ways. First of all, if I substitute z equals to plus half plus j by 2, then you will get the answer of A. Now whatever value of A you will get, it is nothing but it is the complex conjugate value of b, which means the answer of a and b both are same, but only the difference is the b value is a complex conjugate of a, or you can say a value is a complex conjugate of b. Now, which term you are going to solve, that matters a lot. If you solve B first, then calculate the answer, and then it is just, if you want to calculate a value of A, then it is just a complex conjugate value of B. But if you want, you can use shortcut one, but if you don't want, then you can solve the value of A also separately. Now I'm going to do the same thing. I'm going to solve both the values one by one. So I'll substitute first of all Z equals to half plus j by 2. So if I substitute the z value over here, then plus half minus half get cancelled, plus j by 2 minus j by 2 will get cancelled, so whole b will be multiplied with 0 and the product is also 0. So here at this place I'm going to write only a 0, as well as now I will place this value in these two places. Now look at it. 1 plus half is always 3 by 2 plus j by 2, and on right hand side what you will get, half minus half get cancelled, and the next one is here we have plus, so plus j by 2 plus j by 2, answer is only j. Now so to get the value of a, I'll shift this j and this denominator of left hand side, or you can say divide both the sides by j also. Now, we never place j in the denominator. Then what we can do? We'll multiply numerator and denominator by j. So 3 by 2 will be multiplied with j, and here plus. This j by 2 is also multiplied with the j, but j into j is j square, and j square is answer always minus 1 by 2, and here also what we have, j into j becomes minus 1, so here I'm going to write a minus 1. But if I shift this minus 1 or on numerator side, or else you can say that multiply numerator and denominator by minus sign, then what you will get, the answer will be minus 3 by 2 j plus half. Now we can write this real part first and imaginary part in the last. So my a value becomes well, this is the value of a. Well, you can write this value half minus 3 by 2 into j into polar format. Then what will be the result? I'll show you. So we can write this value in polar form like 1.581 at an angle minus 71.56. Now similarly we will solve value for b, or we are going to substitute z equals to perfectly complex conjugate value, so that you will get the answer of b. Now here we are going to calculate a value for b. Now we need to remove the value of a, so we'll substitute z equals to plus half minus j by 2, so that this a bracket will replace by 0. So if I substitute this plus half minus j by 2 in my equation number 1 or equation number 2, so we'll substitute z equals to plus half minus j by 2 in my equation number 2. Now look at here, all the z will be replaced by plus half minus j by 2, but look at this bracket. If I replace this z by plus half minus j by 2, then half minus half, answer is 0, minus j by 2 plus j by 2, answer is 0. So whole bracket is replaced by 0, and 0 into a is 0. So I'm going to replace this whole term by 0. Now I'll substitute z value over here and here. Now as the a term is replaced by 0, that's why I have not written here. Now half plus 1, answer is 3 by 2, and minus j by 2. Next half and half will get cancelled, and minus j by 2 minus j by 2, answer is minus 1. So our b is multiplied by minus 1 into j, or simply a minus j. Now I'll shift this minus j in the left hand side denominator. So what you will get? We never write j in denominator, so we'll multiply minus j in numerator as well as in denominator, or simply j in numerator as well as in denominator. So what you will get? 3 by 2 multiplied with j. Here also this j is also multiplied with j, so j square is minus 1, so that this sign will get changed to plus 1. So I can write here a plus half. But in denominator, if I multiply it with the j, so j into j is j square, and j square gives us minus 1 value, and minus into minus is plus. So this value remains as it is. So my b value is half plus 3 by 2 into j. So as I said, our a value and b value always similar, and we can say that they both are complex conjugate of each other. So if you solve value of a, then directly you can say that the value of b is complex conjugate of a, and hence our answer is half plus j 3 by 2. Now I'll calculate its polar form also. So this is our rectangular value, and this one is our polar value. We required both of them because we don't know if we want to multiply it or if we want to add some values in our next function or next equation, then maybe we require any one of this. Now I'll substitute the value of a and b in my equation number 1. Look at it, I have substituted the values of a and b in my equation number 1. Now I'll multiply this z on right hand side. So what you will get? 1.581 at an angle minus 71.56. This whole value is a constant, so I'll write it on over here, and then I'll write z this value. Next I'll do the same thing with the next one also. Now we can apply inverse z transform on this function. So what we will get? X of z inverse z transform is x of n. Next, this is a constant, so I can write this value like, we can write this value like r at an angle e to the power I theta also, or keep it this value as it is. So I'll write 1.581 this is my constant value. Now z upon z minus a, this is the value of a, minus half minus j by 2. This is my a value. Now if I take minus sign common, then this value will be plus half plus j by 2. Now so my a value here is plus half plus j by 2. Now z upon z minus a can be represented by a raised to n into u of n. So my a value is this, and u of n we know. So we'll write half j by 2 raised to n into u of n. Now similarly we will write the value for next part. This constant I can write as it is. Now again look at here. here I want this equation z upon z minus a. Then what will be the value of a in this last part? My a value will be a plus half but minus j by 2. So if I use this a raised to n u of n formula, then my a value is this and u of n will be multiplied with my a raised to n. So my a value is half minus j by 2 raised to n into u of n. So if you want, then you can take u of n common, and these two brackets will be in addition. And this is nothing but my inverse z transform of x of z with a complex conjugate poles. Similar questions we are going to solve in next video, and while solving this numerical you should know what is the factors or how to calculate the factors, and then how to solve the constant value a and b or whatever you can take by using the complex conjugate poles. So that's all for now. We'll study a new numerical in next video. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.